Okay, in my previous videos in Kinematics, I've been dealing with scalar, vector quantities, distance displacement, acceleration, and now I'm going to be looking at vector analysis and relative positions of motions of one object relative to another on a plane. I'll be answering an exam style question at the end of this video, so stay tuned. If you haven't watched my previous videos, I suggest you do so and subscribe to my channel, and I'll be greatly appreciated. Thank you. Alright, so let's have a look here. We're looking at vector analysis here. We're looking at arrows, and those arrows are positioned in a specific way with magnitude and direction. So the length of it represents magnitude, and the direction represents the vector's direction in a 360-degree plane. Okay, so when we're looking at compass bearings and we're looking at bearings in general, we're going to need to use those directions within our answers and our responses. So vector addition is basically, and subtraction is basically the same. We're just going to move these vectors in head to tail so we can have a resultant. Now, if we have a resultant, we can find that magnitude and direction by looking at what it's doing in relative specs to the first and second arrows, or if there's more. Okay, so we just need to make sure that all the arrows are joined head to tail, and that the resultant basically is the final answer for that question. Now, in terms of looking at a question, you need to make sure that the direction of the vector must be clear and unambiguous. So if we're looking on a compass direction, you make sure that you've got it in a specific order. So let's have a look here at a question. So a car travels north at 50 kilometers for 4 hours. It then travels west for 4 hours at 75 kilometers per hour. Calculate its average speed, displacement, and average velocity. Now, like I just said at the start of this video, if you haven't watched average speed, displacement, or average velocity, then watch my previous videos in Kinematics. Okay, let's have a look here. Now you can see that I've drawn these vector diagrams. So I've gone 200 kilometers north, which is a sum of 50 times 4 hours, and I've gone 300 kilometers west, which is 75 kilometers times 4 hours. Now you can see the resultant there is a dotted line. Okay, so to find average speed, because it's scalar, it's just distance over time, we don't need a direction. So it's just 500 kilometers divided by 8 hours, and it's 62.5 kilometers per hour. Now let's have a look at displacement now. Now, because it's a right angle triangle, we can use Pythagoras theorem. Now, if you can't use Pythagoras theorem, the next law that is more commonly used in class is the cosine rule. But in this case, we can use Pythagoras theorem. So let's have a look at it here. You're just adding 200 squared plus 300 squared, and work out the square root of that answer, and you get 360 kilometers 0.56. Okay, so we've got now the resultants, or the displacement on the resultant vector. Now the angle is, we're going to be using tan, because we're going to find the opposite and adjacent sides to give us the resultant. So we've got shift tan 1.5, which is 56.3 degrees. Now moving on to average velocity. Now I've included the diagram here so you can see that average velocity is displacement over time. So it's a red dotted line divided by the total time, which is 8 hours. So we're at 360.56 kilometers divided by 8 hours, and you get 45.07 kilometers per hour. Now, because it's on a bearing, we're dealing with the quadrant on the top left, which is the fourth quadrant. We're going to minus 360 degrees from our answer of 56.31, and you'll get its bearing at 303.69. I hope you enjoyed watching this video. I tried to explain the average speed, displacement, average velocity. If you are unclear or unsure on how to get those answers, then watch my previous videos. And if you're interested, I'm going to be doing graphing next in my videos. Hope you enjoyed it.